Welcome to section 1.6, which is about solving compound and absolute value inequalities. This is day 7. You should be on page 17 in your packet. Today we're just going to focus on compound inequalities. In the next video, we'll approach absolute value inequalities. First thing we should probably talk about is what is a compound inequality? Well, a compound inequality consists of more than one inequality, or in our case, two inequalities. So the previous video we focused on solving one inequality. Now we're going to solve and graph two of them. So example 1, the inequalities are already solved. We have x is less than -4 or x is greater than or equal to 3. So here's how we would graph that. Okay, so x is greater than or equal to 3. This first one, or I guess the second one, close circle at 3 and everything greater than that. X is less than -4, open circle at -4 and everything less than that. So you're just going to solve two inequalities and you're going to graph both of them. First vocab word that we need to talk about is intersection. An intersection is the graph of a compound inequality containing and. So in example 2, it's one of the and problems. The reason that you know it's an and problem is you have two inequalities put together. You have this inequality and you have that inequality, but they're written as one. Whereas in example 1, we had blank or blank. So we're going to solve both of these inequalities at the same time. It's kind of like having 3y minus 7 less than or equal to 23, and 3y minus 7 is greater than 8. I want to get rid of that -7, so I need to add 7. I need to add 7 to both inequalities. So those 7 become 0. I have 3y is less than or equal to. 8 adds 7 is 15, and then 23 adds 7 is 30. So to get rid of the 3, I'm going to divide everything by 3. 15 divided by 3 is 5. Those 3's divide to become 1, and 30 divided by 3 is 10. Okay, so this is saying y is greater than 5, but y is also less than or equal to -10. So now we're going to graph this one. Okay, so we need an open circle at 5. We need a closed circle at 10. And then because it's an and, so two inequalities written together as one, we're going to shade everything in between. So these are all those numbers that are greater than 5, but also less than or equal to 10. Okay, so moving. Example 3 is another one like that. Right now, I need you to stop the video, and I need you to solve this inequality, and then graph it, please. When you come back, I will show you the answer, but not the work. Please be careful in that you have this -3. Remember that anytime you multiply or divide by a negative number, you have to flip the inequality. In this case, you're going to have to flip both inequalities, just when multiplying or dividing. Okay, pause the video now, please. Okay, you should have had a chance to try this one. We should have gotten 1 is less than or equal to z is less than 4. And then when you graphed it, I don't know why I started out on 2, sorry. You should have had a closed circle at 1, an open circle at 4, and shaded everything in between. So our z can be anything between 1 and 4. It can be 1, can't be 4 though. Okay, so hopefully you got that one right. If not, take a minute to go back and see if you can find your mistake. If you can't, bring a question to class tomorrow, please. So that was intersection. A union is the graph of a compound inequality containing or. So that's like example 1 that we did. One inequality or the other inequality. So here in example 4, we have this inequality or the second inequality. So I'm going to need to solve both. The first inequality, I'm going to subtract 6. So I'm going to end up with k is less than negative 10. Second inequality, I'm going to divide by 3, and I get k is greater than or equal to 14 over 3. And then I need to graph this. It's going to end up being a huge inequality. Okay, so this first one, k is less than negative 10. That means open circle at negative 10 and everything below that. Okay, k is greater than or equal to 14 over 3. That's going to be between two numbers. Now I think 12 over 3 is 4, 15 over 3 is 5, so it's going to be between 4 and 5, but a little closer to 5. It's going to be a closed circle, and it's going to be everything above that. Okay, so unlike the AND situations in example 2 and 3, when it's an OR, you're going to have two different shadings. That's saying that k is somewhere within that region, or k is somewhere within that region. Whereas in example 3, you only had one region of plausible values. So anytime that you have a union or you have an OR situation, you're going to have two shaded parts, and they're going to go in opposite directions. So let's flip the page to page 18, please. Okay, so here is your example. I would like you to pause the video and try this one on your own. Again, take note, we have a negative, we have another negative. Anytime you multiply or divide both sides by a negative, you're going to end up flipping the inequality. When you do your graph, you should have two plausible regions. So pause the video right now and try this one on your own, please. Okay, so the first inequality, you should have gotten g is greater than 3. When you divided by the negative, that flipped the inequality. Second equation, you should have gotten g is less than or equal to negative 3 over 2. Then we should have graphed it. Okay, g is greater than 3, should have been an open circle at 3 and everything above that. G is less than or equal to negative 3 over 2. Negative 3 over 2 is negative 1.5. That should have been a closed circle. And then it's everything below that. So again, you should have gotten two plausible regions. G is somewhere in the blue region, or it could be somewhere in the red region. So hopefully if that one went well. If not, take a minute or two and see if you can find your mistake and fix it. If you can't, bring a question to class tomorrow. Okay, we have two more examples. One word problem and then another union problem, another OR problem. So looking at example 6, it says Cammie is considering painting her room. She estimates that she will need between 2 and 3 gallons of paint. The table below shows the price per gallon for each type of paint Cammie is considering. Write a compound inequality and determine how much she could be spending. Okay, so we're looking at the amount that Cammie could be spending. We're going to need to find out the lowest amount that she could possibly be spending and the highest amount that she could possibly be spending. This is going to be an AND situation, one of the situations where it's the same inequality, because she's going to be spending somewhere in a range. Okay, so the lowest amount she's going to be spending could be if she were to get 2 gallons. And it was the cheapest paint. So looking, the cheapest paint is the flat paint. So we're going to have 2 gallons multiplied by 21.98. The highest she could be spending is if she buys 3 gallons of paint, because it says between 2 and 3, of the most expensive, which is the gloss paint, which is 25.98. Okay, so that becomes 43.96 and 77.94. So this is telling us that Cami is going to spend somewhere between $43.96 and $77.94, depending on how many gallons of paint she uses and the paint type. So she could use satin, she could use semi-gloss. Of those, if she used 2 or 3 gallons of paint, it's going to be somewhere between $43.96 and $77.94. Okay, last one. I want you to pause the video right now. You do get a calculator for this one. Solve both inequalities. This is an OR, so you're going to notice on your number line, you're going to have 2 separate shaded regions going in opposite directions. Pause the video. When you come back, we will go over it. Good luck. Okay, for the first one, you should have gotten J is less than or equal to -7. When you divided by -3, that flipped the inequality. Second one, I would have gotten rid of all of those fractions to begin with. So your greatest common, or your common denominator, is 6. When you multiply everything by 6 and then simplify, you end up with -3j add 4 is less than or equal to -9. Solving that, you're going to get j is greater than or equal to 13/3. Because you divided by a -3, it's going to flip the sign of the inequality. And now we need to graph. I know -7 is going to be on my number line, so I'm going to start with -8. Okay, and then finally graphing, j is less than or equal to -7 is a closed circle at -7, and everything below that. And then j is greater than or equal to 13/3. Well, 12/3 is 4, so 13/3 is going to be a little bit bigger than 4, and it's going to be everything above that. Again, it's an OR, so you should have gotten 2 plausible regions. So j is either somewhere in the red region or somewhere in the blue region. Hopefully if you got that one right. If you made a little mistake, that's okay. Go back and see if you can fix it. If you have any questions, bring them to class tomorrow. I will be checking to see that you have all 7 examples done and that you have the correct work for all 7 examples. Thank you, and see you in class.